Okay, so on the bench today is this. It's an All-American 5. My first and only one. Belonged to my neighbor from across the street. Well, still belongs to my neighbor across the street. I am going to restore it for her and her family. And it's a typical story. It was their family radio, sat on their kitchen for many, many years. And you could tell from here, here, and here, all the oil spots and grease spots. And of course, it's a little beat up. I'll have to clean it up as best I can. We'll give her a first going over. And we'll see what's going on. Now, I'm not going to go into too great detail about the All-American 5 because there are many sites that do them. Let's see here. So, from the outside, you can tell it has lots of household grease on it. This knob, of course, is broken. Unfortunately, freshly, and I can't find the piece for it. Hopefully it's lodged in here somewhere when I take it apart. Right there, see? So I'll put that over there. I did a couple quick checks online. And got the schematic. And it's your typical All-American 5. This one's a little different in that it uses miniature tubes for 4 of the tubes and a regular 50 6L6 for the large tube. I'll see what's inside later. Going over, it's pretty dirty and chomped up. Black Bakelite it's made out of. You can really tell they've used the radio button quite a lot. The volume switch. There is a phono jack, but that seems to be plugged over. Nope, it's still there. That's actually for plugging in a TV, not TV, a phonograph, not earphones. Top's in okay shape. Like I said, it's really dirty. We're missing the RCA Victor side there. It's got a really nice decal on the bottom. A little Master 4. Location of tubes. And use RCA only. Now when I first looked at this, I was looking at these and they don't look like they were original to the body. They look like they were much larger, but I checked online and some of the other ones like this had very similar nuts. You wouldn't want to have that there because of course this is a All-American 5, so the chassis is hot. Anyway, flip her over in the back. Typical back. Warning label, operated Canadian Standards Association. That I think is an antenna hookup. Oh, there. Oh well, I think to start, it does have a big chip out of the bottom. Not much I can do about that, but I will glue or fix the glue anywhere where it's stuck. So, taking it out, 1, 2, 3, 4. That looks like an one. We'll zoom in a bit. Dirty. Yeah, so you see as they went in later, these loop antennas got smaller and smaller. Okay. Can't take that off of there too easily. Let's have a quick look inside. A mix of tubes. My pokey stick here. There we go. Westinghouse, Rogers. That's probably original. That's probably not. That's probably Phillips? No, definitely not original. Lots of dust. Ooh, cobwebs. There's the phono jack pickup. And you can tell that someone's gone in there and replaced the plug there with a proper plug. One side's wider than the other, which is good. And a switch. I might get rid of that anyway. Okay, let's take her out of the box. Okay. Let's put the chassis, the box away for a sec. Have a quick. Nah, no worries. It's another box that fell. Quick look at her. It is dirty. Ugh, filthy. That's no trouble though, but it does look intact. It's moving okay. That's good. A little wiggly. Wheel cloth is in okay shape. Let's look underneath. Well, electrically speaking, it has never been mucked with. Waxies, 1, 2, 3. There's the tuning coil. Electrolytics, 1, 2 diamonds. Don't have to worry about these micas. Lots of, all point to point, but fairly clean. These, of course, have to go. That is probably going to go. So, audio transformer there, and the jack, the volume pot, with an on-off switch. Still seems okay. I'll have to check those rubber grommets under there. They look like they've gone completely solid. No, the grommets still look okay. Probably just needs to be tightened up a bit. That's amazing how that lasts. The underside is nice and clean, except for that. So, ooh, boy, oh boy, oh boy. Yeah, see? This is the problem with this old plastic cable. Let me zoom in again. So, the reason why the old cord was cut out was because this stuff is exceedingly brittle. That's gotta go. Okay. Don't know if you can see that, but right there, if so much as touch any of the wires in here, they break off. The insulation breaks off. Of course, I already cracked that one just by touching it slightly. Same thing over here. There's a big hunk off there that just fell off 2 seconds ago. So, same thing over here. So, it looks like I'm going to have to rewire the whole darn thing. So, let me zoom back out. Wrong way, Feldman. And have a look at what's going on. So, it actually sits quite nice. It was probably designed so you could sit there and work on it like that without any trouble. Ugh. So, I'm going to think of a plan how to do this. I'm going to have to take that off I can clip this out to begin with, because that's got to go anywhere. Actually, I think I can just pull those right off the leads. We'll see. I really have to be careful with this, which I believe... What is that? Ooh. That's the oscillator coil, I think. I have to be really careful with that. Can't really move that or touch that at all, but I can get in there and change these wires out. All I have to do is move the audio transformer out and start taking out all the other wires. So, what I thought was going to be a 4-hour job to clip out 2, 3, 4, 5. 1, 2, 3, 4, 5 caps is going to be a 6-hour job now, rewiring all this thing. So best to start at this end and work this way, rewiring each tube as I go, I think. While I'm busily working away on the cleaning and doing the first fix on the power section of the Little Master 4, I'm going to take this opportunity to explain why it is essential to replace the power cord on old All-American 5 radios with a modern polarized plug. By the time this radio was introduced into production in the late 40s and early 50s, the safety features of the All-American 5 had improved greatly since the early days of the 1930s, when all that was separating you from a nasty main shock was the cabinet and the knobs. In later versions of the All-American 5, like the Little Master 4, a dual wiring system was introduced. Here we have a common ground. You can see there were about 16 different points in the schematic, which I've marked in blue, that hooked the differing parts of the circuit into one common ground, hence the name. Now, don't get this term mixed up with the term star ground. You will not see that used in any schematics. It is normally just used by us techie types to refer to a point where a number of circuit leads connect to ground. This radio actually has 2 star grounds. Both are in the center of the chassis, and I've highlighted them, one in red and next to it one in green. Now going back to the schematic for a second, you can see where I am marking all the chassis grounds. There are only basically a few. The IF cans, the phono jack, and a single grounding point. The whole idea behind wiring the system like this was to achieve some form of isolation from the mains without going to all the expense of providing a transformer. Isolation was achieved in a number of ways. For example, rubber mounting grommets were added to the tuning capacitor, thus isolating the tuning dial. Now, the main isolation solution the Boffins who designed the radio came up with was this low-value cap, which I am marking in green. Oops, I noticed there's something interesting going on in my little side project. Let's have a quick look there then. Oof. When you look at it, there's your signal going right by the heater. You wonder how much hum that would have caused. It was right next to the heater. Okay, I guess I'll have to address that later. Now back to our schematic. With this system, if you ever happen to complete the circuit to ground, that small cap would provide something called capacitive reactance to the mains voltage, i.e., at mains frequency, it will act like a large value resistor, something like 27K. Thus, you would not be hit by the full 15 amps of mains voltage, but by about 5 milliamps. Not a fatal amperage for sure, but a rather unpleasant experience nonetheless. As a bonus, this isolation cap also filters out some RF noise that might be present on the mains line. Though given the way that these radios were put together with little regards to hum or other noise, I think that was just a lucky accident. Now, if you look at the big picture and I color in all the different parts of the circuit in their respective 2 colors, you can really see the way how a chassis ground cut down on hot parts of the radio. Now to get a little bit back on track and check out why we use that polarized plug. So let's zoom in right now to the power portion of the schematic. And here we'll use red for hot and green for neutral. So if I plug in my cord correctly into a socket, you will see that all the circuits on the radio are connected to the neutral with only a small bit behind the switch having a hot connection. Now, back before there were 3-prong sockets and polarized plugs, there was an equal chance that you could plug it in with the hot in the opposite side. all of a sudden all the circuits on your radio will hot. Fortunately, that little capacitor was there, so at least it would limit the current if one managed to somehow complete a circuit to ground when you were plugged in backwards. Now that was fine in the 40s and 50s. It even got a CA safety stamp. If we jump ahead 60 plus years since this radio, I can tell you for a fact that this particular waxy is leaking and will not provide the expected capacitive reactance. More than likely, it's only a few ohms of resistance, or it could even be shorted. So now, no matter which way our radio is plugged in, it will make a hot chassis. So we're right back to the old All-American 5 of the 1930s vintage. Now, by using a modern-day polarized plug, we can eliminate this shock hazard. That's assuming, of course, the socket you're plugging into is wired correctly. So just on the off chance, in case someone is plugging this into an incorrectly wired socket, we can replace this old waxy with a modern-day Y-cap. A Y-cap will fail open, thus separating the two grounding paths. Now, of course, your radio won't work anymore, but that's a problem for another day. Now, the last thing we do is to add in a fuse before the switch, and we are somewhat safer now. Now, with all that being said, these are improvements for the consumer end of the radio, not the service person. The radio is still dangerous to work on. You will need an isolation transformer and the smarts and experience to know how not to zap yourself. Well, it looks like I'm shooting black in my little screen down below, and I've made all my points about circuit changes to make All-American 5 radios more safe. So let's just fade to Riley and wait for the next installment on this project. Can you come and help me? Come on, Riley. You know you like these valve projects more than transistors. Come on. Let's go down to the lab. No? You sure? You sure you don't want to come down to the lab, Riley? Ah, here you come. Come on, let's go down to the lab.